Hi guys, welcome back. In this video, we're gonna start to round off our conversation on the properties of exponents, section 1.6. So just to recap, last time we talked about negative exponents. We motivated this definition, but really we just have to remember what it is. If you have a to the negative n, it's the same thing as 1 over a to the n, and of course this is provided that a is not 0, because then this would mean dividing by 0 down here. Awesome. So the next thing we'll do is we'll just kind of apply our definition and simplify some fractions that involve negative exponents to see some examples. So yeah, let's check them out. So let's start with 4 to the negative 2, our first example here. Well, just strictly applying the definition, 4 to the negative 2 is the same thing as 1 over 4, and then remember you change the sign of the exponent. So since we moved it down, it changes the sign, it becomes positive 2. It goes from negative 2 to positive 2 when it gets moved down. And now 4 squared we can actually just evaluate. So on the top we'll still have 1, and 4 squared is 4 times 4, which we know is 16. Awesome, that's the first example. The second example, we have 3 to the negative 2 times x to the negative 4th over 9 to the negative 1st times x to the negative 8th. So notice we got negative exponents all around. Typically by convention, we don't really like dealing with negative exponents. We like to move things so that they're positive exponents and then simplify. So let's see what happens when we do this. So let's move everything that has a negative exponent from where it is to the other part of the fraction. So let me be a little bit more specific. Let's start with 3 to the negative 2. We want to move that down with the definition. So this is the same thing as 3 squared on the bottom, right? We keep the number, we keep the base the same, we just change the sign of the exponent and move it down. Next, we'll have x to the negative 4th. Similar idea. We keep the base the same, we move it down, and we change the sign. So now it's positive 4 instead of negative 4. Next, now it's a little bit different, but it's still the same thought process. Now we're in the bottom. Here we have 9 to the negative 1st power. That's the same thing as 9 to the 1st power up here. And then lastly, we've got x to the negative 8th. That's the same thing as x to the positive 8th up here. Awesome. Now let's just simplify a little bit further. So notice here in this first fraction, we've got 3 squared in the bottom, right? Well, let's think that's the same thing as 9, because it's 3 times 3. So really here what we've got is we got 9 over 9. 9 over 9 is just 1. So I'll write the 1 for emphasis, but we really don't need it. And then we've got x to the 8th over x to the 4th. And we'll apply the quotient rule here. We've got x to the 8th over x to the 4th. That's the same thing as x to the 8 minus 4, subtract, and so we just get x to the 4th. Awesome. So there's our negative exponent review with some examples. Now what we're going to do is we're going to move on to what's called the power rule. We'll wrap up the video with motivating the power rule and then stating what it is. So let's motivate it with an example. Let's look at another example. Let's say we have, this is example 1 for the power rule. Let's say we've got something like 2 to the 3rd, and say it's raised to the 2nd power. Let's think about what this means just by definition first, right? The definition of exponentiation. So really what this means is whenever you have an exponent, it means repeated multiplication. So this means the same thing as 2 to the 3rd. Sorry, that's a 3 up there. 2 to the 3rd power times 2 to the 3rd. We just have two of these, right? Here, I won't write that. But we have 2 there's two of these, right? And we have 2 to the third written twice. That's what this means by definition. 2 to the third times 2 to the third. Now this is the same thing as 2 times 2 times 2, right? 2 to the third is the same as 2 times 2 times 2. And again, 2 to the third is 2 times 2 times 2. And now let's just combine all of these together and let's see what we get. We've got 1, 2, 3, 4, 5, 6 of them in total, right? So we've got 2 to the 6th. So now this serves as a motivation for, or rather, this will allow us to generalize what happens when we have a to the m raised to the nth power. So when we're generalizing, we're looking at a more general instance of this. See, like a could be any real number, and m and n are considered to be integers here. But yeah, let's actually see what the rule should be. Well, notice we had 3 and 2 here, right? And at the end of the day, we ended up with 6 2s. So it seems to stand to reason that a to the m raised to the nth power is a to the m times n, right? We had 3 and 2, and note 3 times 2 gives you 6. Well, this is the power rule right here. This is the power rule. It says a to the m power raised to the nth power is a to the m times n. Or with this example, 2 to the third squared was 2 to the 6th. So to kind of summarize, we multiply exponents in this case. All right, that's it for this video. In the next video, which should be the last, we're going to talk about raising a product to a power, and we're going to talk about raising a quotient to a power. We should do a couple examples with each of those, and that'll be the last video for 1.6. I don't want to overload you guys too much, but I want to give you all the resources you need to succeed. So in the next video, we're wrapping up 1.6, and that's the end of this video. So I hope you have an awesome day, and we'll see you in the next video.